Yo, this is the last lesson with like maybe 1.5 new things. Okay? We have a review day Friday. We have a test on Tuesday. One of your test questions will be a free response question. The free response question will be the exact same format and type of question that you will see on the actual AP exam. How do I know this? Because they told us. It's very kind of shocking, but go to this page. This is not true for any other AP exam that I know of. Definitely not true for the AP Calculus exam. But when they introduced this course, they're like, hey, you're going to have 4 free response questions, and question number 3 will always be modeling some sine or cosine graph. Always. Okay? One of your test questions on Tuesday will be this question. This is your free response question, multi-part. It's worth, I don't know, some percentage of your test that we have determined. Okay? Now, yeah, pretty much. Just like all the modeling questions are the exact same questions with different numbers, right? No, it's going to be different probably. But like I said, it's different wording, but it's the same situation, okay? Now, here's one new thing, okay? Again, all of this unit, 80% of this unit, I was just talking to myself, 80% of this unit is day 1, okay? 80% of this unit, you have to understand day 1. Here is like an additional 5%. Okay. What? Concept of like frequency, something new, okay? We got a point B on a fan. The fan is rotating. We're going to be modeling the height above the desk or this level. This is a level 0, modeling how high that point is on the fan. Cool? The electric fan rotates in a clockwise direction and completes 5 rotations every second. This is not something you've kind of seen yet. So this is new. And my question is the period 5? Does that mean B is 2 pi over 5? Take it. Is that your period? Okay, this is where we go back to the beginning of the notes and we talk about the new 5% or 10%, okay? The idea of a period when it comes to frequency. Now, we're not going to worry about frequency. I'm just going to kind of focus on period. So if I ask you what is the frequency, I'm really just asking you what is the period because that's what's important, okay? They're just like reciprocal of one another. Here's the key. Is understanding what a period is. A period is how long, typically a time, it takes to complete one cycle of your situation. That I should have written up here so I had more space here. But period equals how long it takes to complete one cycle. Okay? A wheel rotates at a constant rate. It completes 12 rotations every 3 minutes. What is the period? Well, you will understand that we want the time it takes to complete one cycle? Well, it takes 3 minutes to complete 12 rotations. A full rotation we consider a cycle. You could simplify that to be 1 minute to complete 4 cycles. Or like we did back in Unit 1, with like rates of change, you could turn this into a minute per 1 cycle. 1 divided by 4 is the same as 1/4 divided by 1. It takes 1/4 of a minute to complete 1 cycle. It's the same. The period is this 1/4. Stepped out, 1/16 to get to the next part, to get to the next part, to get to the next part. Got it? Okay, do the next two. What is the period of a doggy breath? What is the period of the satellite orbiting the moon? Oh, I have a Diet Coke in the fridge right now. I'm going to get it. I won't get it in like 2 seconds. 2 seconds to complete 3 cycles of breath, which means 2/3 of a second to complete 1 cycle. That's your period. Don't forget, period equals 2 pi over b. B equals 2 pi over the period. On your homework, I give you like a situation. I ask you to find the period. I ask you to find b. So understand the period is the time it takes to complete 1 cycle. Understand b is different. You know, b is the dilation 2 pi needs to undergo to get that period. Understand if you shift things, any phase shift that comes into play, you apply your period off of your phase shift. This one is kind of tricky. 13 hours to complete 1 orbit. The period is 13. I was just trying to trip you up there, trying to get you to put 1/13. Anybody do that? Anybody do that? Anybody do that? Anybody do that? Yeah? Okay. You did great. All right, now. Please do the following. Based on the fan situation, write down everything you know. Give me a y equals cosine model for the fan spinning. Go. How about this? Let's do it one at a time. What's B? What's the period? What's B? Let's work on that because that's really what the new thing is. Everything else I'll just work with you. It completes 5 rotations every second. That is 1 second to complete 5 cycles. This is 1/5 of a second per 1 cycle. The period is 1/5. This is very important, this understanding of how many times.
B is 10 pi.
B would be 10 pi. B equals 2 pi divided by your period. B equals 10 pi. That goes right there. That won't change. Now, The rest of the stuff will make sense provided you understand the situation and the context. The center of the fan is 20 inches above the ground level. Okay, that's your midline. The length of the fan is 6 inches. That's the radius. That's going to be your amplitude. Nothing else is new. You should be able to get your midline. You should be able to get that. You should be able to figure out what your graph looks like. You should be able to put together however many different models to understand your situation. Please label all 4 of your important points on your x-axis. Now you know what D is. Now you know what A is, maybe. You know A, you know the amplitude is 6, but understand you could have like a positive or a negative. What does your graph look like? What are all of your points on your x-axis? Go, figure it out. Your period is 1/5. Your step is 1/5 divided by 4, or 1/20th. You step a 20th. 2 20ths is a 10th. 3 20ths. 4 20ths is a 5th. You read the directions for it, and you see that the point B is located directly above the center of the fan at time t equals 0. They are showing us at t equals 0, this is where point B is. What does that show up as on the graph? Your maximum. Well, sure, but I could ask you for sign. Could you give me the sign? I hope you can. Good. Or else you didn't do well on your quiz today. You know what I mean? This is the graph that we're looking for. We have all of our points we need. We now have C is 0 and positive 6 is good. Okay, everybody give me the model using sine. Give me the model using sine. My amplitude is still 6. I'm going to wait to see if I make it a negative. My B is still 10 pi. I'm going to look to shift. My midline is still 20. Now I got to figure out my phase shift and whether I want A to be negative to do a vertical reflection. My parent function starts at 0, 0, and goes up to 1. The sine of pi over 2 is 1. My parent function likes to go up for sine. If I decide to shift my parent function over 1/20th to the right, and then up 20, I get to this point, and I notice that this point is the point where we start to go down. If you'd like to do that, that's fine. You shift to the right 1/20th, but you make your A negative to do a vertical reflection of your parent function. If you'd like to shift to 3/20 and use positive sign, do that. If you would like to go in the opposite direction and shift your graph of your parent function left, which means this becomes a plus and this becomes a positive 6, do that, and that's okay. Now, everything you just did will be asked of you in weird AP free response ways. Flip the page. This is the exact questioning that you will have on your free response question on your test on Tuesday. Everything you just did will answer this question. But again, it's going to be wordy because it's a College Board question. It's going to be like trying to confuse you. Don't let it confuse you. The graph of H and its dashed midline for 2 full cycles is shown. 5 points FGJK are labeled on the graph. No skills indicated and no axes are presented. Determine possible coordinates for T, H of T for the 5 points FGJKP. Oh, that's so confusing. No, it's not. It's not. It's exactly what you just did. 26-2014. 26-2014. 0, a 20th, a 10th, 3/20th, 1/5. 0, a 20th, a 10th, 3/20th, 1/5. It's the same thing. You know the points. This is 0.26. This is 1/20th, 20. This is 1/10th, 14. This is 3/20th, 20. This is 1/5, 26. Like, you know that. That's not crazy. Zoom out. What just happened? Okay. Oh, give me a sign. Yeah, you just did that. Okay, fine. Just make sure you pay attention to the one they asked you. They asked you for the sign one. We already did that. Okay. Part C. Oh, this looks really crazy, but it's not. K is T1, P is T2. What is true about H on the interval T1 to T2? Between K and P, what's happening? Tell your neighbors, A, B, C, or D. Now, the graph is increasing concave down, correct? Well, it's asking you, is H positive or negative? That's not the rate of change. H is positive and increasing because these values are between 20 and 26, and they're going up. But then look at the next question. What does the next question ask? Answer that question and tell your neighbors what the answer to C2 is. How is the rate of change? Bingo. Decreasing because H is concave down. The rate of change of H is decreasing. Cool? So, like, guys, the free response question in your test Tuesday, the free response question 3 in May, whenever we take the AP exam, you all should crush, okay? You should get 9 out of 9 points, or however many points this is worth. I think it's worth 6. I don't know. Get it right. 6 out of 6. It shouldn't be hard. You know what to expect, and we will practice it before we get there. Yes, Linda?
Are we only asking one free response question?
Yes. Yep. I don't think it's going to be 50%. We haven't decided yet. Okay? You're going to be like 20 multiple choice questions. How many parts is this? It's like an A, B, C. It's worth 1, 2, 3, 4, 5, 6. I would say we're going to count those 6 points as 6 questions. So I would say, like, it's worth what? Practically a quarter of your test, a little bit more than a quarter of your test. Cool? 6 out of 26. If there's 20 multiple choice questions, it's 6. A little less than a quarter. What is it? Great. Okay, yeah, it's less than a quarter. It's more than a fifth. Great. Look it up. All right. Other way around. Here's the last 10%. Six out of 26. Oh, you just take courses over the summer. Ask Iron. Iron took I took algebra 2 over the summer. Thinking that was a smart idea. What? Took geometry over the summer.
Why would you do that?
Because it looks good. Right? All right. I know. What does the graph of tangent look like? Now, we're going to keep this simple. We know our unit circle really has 4 key points that help us understand like the graph of sine and cosine. What are the 4 key locations in our unit circle for the parent function of sine and cosine? Tell your neighbors. Good. All of the extremes, 0, pi over 2, pi, 3 pi over 2, 2 pi, which is coterminal with 0. Okay. Guys, don't let me down right now. Okay? Please don't let me down right now. What's the tangent of 0? Don't let me down right now. Everybody figure it out. It's a Torah. It's a Torah, guys. It's Torah. Not owl. Not owl. It's Torah. Not owl. It's the Oa.
What can you say all again?
It's the Soka Torah. Yo, it's the opposite over the adjacent. It's the y over the x. Come on, guys. What's the y at 0? It's 0. What's the x? It's 1. The tangent of 0 is 0. Okay, guys, put down 0, 0. Okay, what's the tangent of pi over 2? Don't let me down here.
Undefined.
Oh.
No, it is. 1 over 0. Undefined. So tangent.
It is y over x, which is 1 over 0. You're going up 1. You don't go left or right. That's undefined. Okay. This is 0. This is pi over 2. What the heck does undefined look like on a graph? Let's go back to the first semester and the rational functions unit. Whenever we got a number divided by 0, what did that look like? Tell me. That's not nice.
Sorry. I don't know.
It is a vertical asymptote. Great. All right, let's go to pi. What's the tangent of pi? What's the tangent of pi?
0.
What's the tangent of pi? Who's waiting for me to write something down, and who's already written it down? That's my question. Who is waiting for me to write it down, and who's already written it down? All right, cool. So this is interesting, people. I guess let's go a little bit more. What's the tangent of 3 pi over 2? What's the tangent of 3 pi over 2? Undefined. Okay, I got another asymptote. What the heck does this graph look like? I have no idea. Okay. Lock it up, cool kids. Okay, what the heck does this graph look like? That's the question. Now, let's fill in some gaps. And if we wanted to, we can go back to negative pi over 2, which is coterminal with 3 pi over 2, get another pi. Okay, so let's fill in some gaps because I don't know what this graph looks like. All I know is I got a 0, and a bunch of dotted lines. What's an easy tangent value? Pi over 4. Pi over 4 between 0 and pi over 2. Smack dab in between. What's the tangent of pi over 4? Don't let me down right now. 1. Would the tangent of pi over 3, which is closer to pi over 2, be a value bigger than or less than 1?
It's root 3, a little less.
Less? What's square root of 3? 1. Oh, the block is now thinking like a SOHCAHTOA. Opposite over adjacent. What's happening if I go to pi over 4 to pi over 3? The opposite gets bigger, the adjacent gets smaller. Bigger y, smaller x. Bigger result. Root 3 is like 1.7. What if I put an angle closer to pi over 2? Bigger y, smaller x. Now we're starting to divide by decimals. Like we're dividing by a half, we're dividing by a quarter, we're dividing by 0.1. What's going to happen? It's going to go off towards our vertical asymptote in this direction. Why? Because tangent's positive in this quadrant. Tangent is positive. We got opposites over adjacents, y's over x's that are positive. Okay, well, let's move on to this value between pi over 2 and pi, which is 3 pi over 4. What is the tangent of 3 pi over 4? Don't let me down right now. What is the tangent of 3 pi over 4? What is the tangent of 3 pi over 4? Tell your neighbors. Keep it quiet. What is the tangent of 3 pi over 4? No. It's not the same thing. That is not correct.
It's -1.
What is the tangent of 3 pi over 4? Don't let me down. You're all letting me down. I'm a little bit disappointed. 3 pi over 4. Oh. -1, guys. -1. Now tell me, am I going to be coming from positive infinity or negative infinity? Yeah, well, why? In the second quadrant, what's your tangent value? Negative. Because you got a negative x and a positive y. So it makes sense we will be approaching negative infinity. And again, if you thought like a SOHCAHTOA, very close to the pi over 2s will be producing very, very large values. We will then pass through pi. Let's go to this value between pi and 3 pi over 2, which is what radian measurement at a pi over 4 is between pi and 3 pi over 2. Thank you. What is the tangent of 5 pi over 4? Please tell your neighbors. What is the tangent of 5 pi over 4? What is the tangent of 5 pi over 4? The tangent of 5 pi over 4 is negative root 2 over 2 divided by negative root 2 over 2, which is positive 1. And guess what? In between pi over 2, in between pi and 3 pi over 2, we have positives because in the third quadrant, positive. What we find is this is the graph of the parent function. We have zeros at the horizontal. 0, pi, 2 pi, 3 pi. We have undefined at the vertical. Negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2. Depending on the quadrant we're in, will either be coming from negative or traveling towards positive. What is the period of the tangent function? I know, it's unfortunate. It's really unfortunate. It's like, I would rather, I know, I should. How long does it take to repeat your graph of tangent? Pi. This is very important. This is the one thing that is different between tangent and sine and cosine. The graph repeats. That's the same, okay? It takes the entire circle for the graph of sine to start repeating. It takes the entire circle for the graph of cosine repeating because, and here's the big reason why, you have two adjacent quadrants with the same values. Sine, positive, positive, negative, negative. You can't start repeating until you get through both positives and both negatives. Cosine, positive, negative, negative, positive. You can't start repeating until you get through both of those negatives and both you start repeating back to the positives. But tangent, positive, negative, positive, negative. We start repeating the signs and we will start repeating the values because tangent signs flip-flop. That a phone in your lap, Mansky? All right, good. Just checking. I always like to catch people looking down at fingers moving. So, here's the key. Tangent. Tangent has a period that is pi, which means if you do any sort of transformation, your period will equal pi over b, or b equals pi over the period. Now, remember, your key, your horizontal are your zeros. That's 0 pi, 2 pi, 3 pi. Your vertical asymptotes are at your pi over 2. Okay? Flip to the extra example because I don't like those. Actually, let's just start over. Just erase this. And erase this. Tangent X. I asked you to graph this. Okay? That's it. Now, don't look above. We're going to do it on the box like we did with sine and cosine. It all depends on where you want to start. I like starting on the left. I think if you watch Huffaker's video, he starts 0 in the middle. But whatever. I like starting on the left. I like starting a midline in the middle. We aren't going to worry about maxes and mins. We are going to worry about a 0, an asymptote. A 0, an asymptote. A 0. You don't worry about this. I don't care. I don't care. If you want to, you can make this like 1 and then have like pi over 4 in between. But honestly, we're going to keep it simple. 0, this is pi over 2. We repeat our graph at pi. We get another vertical asymptote. We repeat our graph 2 pi. Tangent's positive in the first quadrant. It's negative in the second quadrant. It's positive in the third quadrant. It's negative in the fourth quadrant. We just did it. Don't copy it down. You should understand. You should be able to recreate. Guys, this is the parent function. Whether you want to shift it right or left or whatever, you'd be fine. Now, what would happen if g of x is negative tangent 2x? Now, here's what's tricky. Pi is your period, right? Here's your deal. Your period is pi, horizontally dilated by a factor of 2. My period is pi over 2. Horizontal dilation Schreier, pi over b. Period is typically 2 pi over b. The period with tangent is pi over b. The period is pi over 2. But guys, watch. That doesn't mean this distance is pi over 2. You're going to go 1 period to pi over 2. Now you want to step it out? Find what half of that is. Oh, that's pi over 4 to pi over 2 to 3 pi over 4 to pi. Your vertical asymptotes will stay in the same location, but now you can kind of see, oh, they're going to be at pi over 4 and 3 pi over 4. Your zeros are staying in the same location. Your graph, just like what we're used to, stays still. What changes is your axis. But hold on, I made a huge mistake because I forgot about something. Yeah, so what happens? Yeah, it flips. Good. Flip. 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 Now, honestly, what we could do is stick to like my period is 2 pi over b, but then we kind of lose key things if I give you words. For example, go to the back. What's the period of this equation? Yeah, great question. What's the period? Thank you. Everybody's saying 5. You're paying attention to me. I really appreciate it. Those of you who said 10, you're still in 2 pi over b land. The period of tangent is just pi. In our box, we do 2 periods of tangent. Pi over b is just going to be 5. That's going to be very important for your test. Most of the stuff with the steps, oh man. We'll be fine. All right, ready? Y equals tangent pi x minus 2 plus 3. What's your graph look like? Find on your back some more space to do that. What's your graph look like? What's your graph look like? Now, you're going to have to get used to it. What do we have for the parent function? Zeros at the horizontal, undefined at the vertical. If this is what you remember for your start, you're good. This then repeat. First quadrant tangent's positive. Second quadrant tangent's negative. Third quadrant, start repeating. We've gotten through 1 period in 5. Keep repeating. Okay, now, this is at y equals 0. This is at x equals 0. Adjust. Now, watch this. What are your horizontal transformations? A dilation, take your x's, divide by pi. A translation, take your x's, add 2. take your x's, divide by pi, add 2. You can do that. Yes, ma'am. What do you mean? Yes, the thing, we got to understand, it's all about like perspective and scaling. Yeah, the graph's not going to change. But what changes is your axis. What changes? No, but it does. It does. It does. So, bang. My new start is at 2. Okay? My period.
I meant by like the transformation, it does nothing on the overall.
You're saying like this and this looks the same. No. If you're doing a horizontal dilation, you are horizontal. If you can do the proper dilation and transformation, sure, you can make a graph look like another graph, right? I don't think that's right, Bang. No, do it. Show me your equations that you're talking about. All right, ready? Yo, my period is 1. That doesn't mean I go to 2 to 3. I go 2 to 3 to 4. My step size really is dividing this by 2, so I go 2.5. I go 3.5. On your main values, you have your zeros. In between your zeros, you have your vertical asymptotes. You are shifting things up 3. This is what my graph would look like. If you're comfortable with that, you're good. This is how I like to do it. Off might move things around. Are you guys okay with this? What would happen if I put a negative in front of it? What would happen if it's a -2? Yeah, so it just like goes quicker down. But it's going to look the same, and we actually don't care. What you will notice on your question in the middle of your extra example, many of the questions won't distinguish what A is as an amplitude, but we will distinguish the sign. Answer the question in the middle of your notes on extra example. All right, what do you got, Fang? What's your equation that's going to be a dilation and a transformation and be the same situation? Sure. Right. Sure. Yeah. No, you're right. Well, that goes for all of the trig functions. Yeah, no, I hear you, bud. Like, good. If you kept going, you would have a 0 at. But no, because of the dilation thing, that makes a big difference, right?
The dilation does.
Yeah, the translation. The translation. That's what you're trying. That's what you're saying. You're saying like, you do if you translate pi, you have the exact same graph as tangent.
Is it B?
4. This, we should be stretching and flipping. No, it's not B. A is negative. It goes down. So it's D. A is negative, and B is less than 1, so that I dilate it. What's the period? The period is going to be 2 pi. The period is normally pi. What are you looking at? Stop looking at grades. What are you doing? You guys are just bad kids, huh? Look at other people's grades. You want to like answer my emails while you're here? Yeah?
Did you send me an email? Oh.
Sure, you want me to send you an email?
We gotta catch up.
What? Sure, Thomas. If you got an extra period and you need spots to fill, I love to. He leaves for free. Do you know what the